Good day, grade 12 learner. How are you? I am good. So my name is Tifla. So I'm going to be showing you trigonometry. So we are going to do trigonometry, but first let's just recap on grade 11 work, right? So this is just a revision of grade 11. So after the revision, we can go to compound angles, right? So how I like to teach this trigonometry, maybe it's different from the way others teach it, but I really enjoy the way that I teach this trigonometry. So firstly, I'll talk about this theory of mine that I have. So I've studied and I've seen that trigonometry is all about 6 types of trig questions. So there are only 6 types of trig questions. If you check mostly in grade 11 question papers, in grade 12 question papers, there are only 6 types of trig questions, right? So we are still talking about the part 1 of trig, right? The part 1 of trig, which is mostly about the identities and stuff like that, without talking about the 2D, 3D, and without talking about the functions, right? We are still talking about that first part. So there are 6 types of trig questions. Once you know this type of questions, you can crack trigonometry like nobody's business. You will be a star, you'll be a hero of trigonometry. So the first 2 types are the same. So the first 2 types are the same. You solve them with the same method, and the other 2 also are the same, and the last 2 are the same, are also the same. So these 2, they are all the same. So before I can begin with the grade 11 revision, I will show you this type of questions and you will recognize them. After recognizing them, we are going to talk about the tools that can help us to solve them, and then I'll solve those questions, and then we'll be done with the revision, right? So yes, let me just type all these 6 types of trig questions, and I'm sure you recognize them. Yes, here we are with my 6 types of trig questions theory, right? So the first type of question, it is this one. You're given if tan 38, like for example, is equals to k, and then solve the following in terms of k. So in terms of k, right? That's the first type of trig question. And the second type is when you're given if 7 sin theta plus 4, for example, is equals to 0, and cos theta is greater than 0, and they say solve for the following, right, in terms of that which you are given, right, or without using a calculator. So as you can see, this type of question and this type of question, they are the same. If, like they are the same, right? That's my theory. So I said the first 2 are the same. So let's move to the next 2. So here they said simplify. So we are just simplifying this, and I'm sure you recognize that this is how your question paper comes. Grade 11, grade 12, it is still like this. The first question, the second question, simplifying, proving, right? You have to prove the identity. So if you can check, simplifying and proving, they are more like the same thing. Just that on simplifying, you don't have the answer that you are working to. But in prove that, you're actually having the final answer that you must prove to. But they are actually the same. You work them using the same methods, right? They can come in different types, but they're the same, right? So I'll advise you that after we are through with this trigonometry, please try to do so many questions. If you're having some question papers that you think like you're struggling with, I've posted my Google Drive on the bio, or I'll also leave the link in the description. You can also get on that. There's a folder that I made there that is written post your work, right? So you can post whatever or any question that you're having, and I'll attend to that and I'll help you with those questions, right? You can just leave it there. So the next two types of questions, it is general solution and solving for theta. So you cannot solve for theta without general solution. So you see these last two also, they're the same, right? So before I can solve all this, have you subscribed? Please, if you haven't subscribed, please just rush to subscribe and come back so that we can continue, right? But as I said, I'll first go through the tools that can help us to solve all this. And then after talking about the tools, now I'll talk about which tools you apply there and there and there and there and then. And also you'll be checking, you'll be seeing how this is done, right? So just let me cook. So let's talk about the tools that can unlock all this. So with some of the tools, I won't be so much in details because some of the tools, they are stuff like grade 10 work. But let's just get straight to it without wasting time. So let's see. So first thing first, before I can go anywhere, the first tool, so tool number 1. So we know from grade 10 that sine of theta is equals to opposite over hypotenuse, and cos of theta is equals to adjacent over hypotenuse, like that, and tan of theta is equals to opposite over adjacent. But when you go to grade 11, we learned that trig can be done on a Cartesian plane, where we're having something like this, and this is our r, this is our y, this is our x. So all these tools, like the most boring thing about trigonometry is that it's full of application. So once you don't practice this, you won't get it. So the biggest medicine or the biggest motive there is to practice. Always practice. So I always tell my students that there is no something for nothing. So you cannot get something without any work, right? So you have to do something to get something. You cannot get something by doing nothing, right? So practice, 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 and I'll help you with this, right? So don't worry much. So when you go to grade 11, we learned that sine theta is equals to y over r. Cos of theta is equals to x over r, which our r is always positive, right? And tan of theta, it is y over x. So that's our tool number 1, just by knowing that. So I want you to just know this, and I'll show you how to apply, right? Just know this. Knowing this is enough. You know this, I'm sure. So let's go on to our second tool. So from our first tool, we also know that here y is positive. Also this quadrant y is positive, so also here y is positive, but x is negative, and here x is negative, y is negative, and here x is positive, but y is negative, like that. So now we have learned now again that in all the ratios are positive in the first quadrant, only sine is positive in the second, only tan is positive in the third, and only cos is positive in the fourth quadrant, right? So which means that sine, so if we're having the first, second, third, and fourth, right, which makes our sine of theta positive in the first, positive in the second, but negative, negative. And our cos of theta makes this positive, negative, negative, positive. And our tan of theta, now it will be positive, negative, positive, negative, like that, in these quadrants, right? So that's tool number 2. Do you know this? Just knowing this, do you know where sine is positive? Do you know where cos is positive? Just by knowing that, it's enough, right? And the third one, I should have just started with this actually. So this is the theorem of Pythagoras, right? The theorem of Pythag. So which, just knowing that our x squared plus our y squared is equals to r squared in a right angled triangle, like that. So that's our tool number 3. Do you know the theorem of Pythagoras? Do you know how to use it? Right? So I'm sure you know how to use it. So we can go to our tool number 4, right? So tool number 4, let's get to it. So this is our x, our y, right? So this is about reduction formulas, right? How to reduce angles that are greater than 90 degrees. So we know that in the first quadrant we use the reduction formula theta. In the second we use 180 minus theta. In this quadrant 180 plus theta. If you don't know this, please revisit this, right? And you can also check in our playlist. We are also having this work on grade 11 work. So this is how it is, right? So I didn't write the 90 plus, 90 minus, 270 plus. I'm avoiding them because they are called the co-ratios, right? Sine can change to cos and cos changes to sine, right? So according to this, in the quadrants, in the second quadrant, sine is positive, cos is negative, tan is negative, cos negative, tan positive, sine negative, cos positive, sine negative, cos tan negative, and cos positive, right? Just like that, right? That's our tool number 4. So now we can move to our tool number 5, which is the stuff that I was avoiding actually. So these are the co-ratios, right? So on the co-ratios, I'll just write this simple stuff. So if we're having cos of 90 minus theta, this is the same as sine theta. If we're having cos 90 plus theta, just because it's in the second quadrant and cos is negative, this becomes negative sine of theta, right? Can you see now, if we are using 90 minus or 90 plus, cos always changes to sine, like that. But now just because you said cos 90 plus theta, it's in this, and cos is negative, so it will make this negative as well. But sine is positive there, but this, just because it is negative here, it will make this negative, right? And also sine 90 minus theta is equals to cos theta. Sine 90 plus theta is equals to cos theta. So nothing is changing there, right? So that's number 5. So on number 6 is just knowing the special angles, right? That we're having 30, 45, 60, 0 and 90, right? And I know you know all the tricks how to use the calculator when they say don't use the calculator, right? So I will not talk about this special angles stuff. Special angles, right? And tool number 7. So this tool number 7, we actually use it when we are dealing with general solution, right? So this is to know the periods, right? So the period of sine theta is equals to 360 degrees. So the function of sine repeats every after 360, and we also have the cos of theta, it is also 360, but the period of tan, it is 180 degrees, like that, right? So now let's move to the last tool that I will talk about, which are identities, right? So the last two I will talk about, grade 11 work, they are identities. So our identities in grade 11 work, we know that tan of theta is equals to sine theta over cos theta. So it means that our 1 over tan theta can become cos theta over sine theta, right? And another identity, we know that sine squared theta plus cos squared theta is equals to 1. So which will mean that if we move each either way, it will mean that our cos squared theta becomes 1 minus sin squared theta. Don't forget this. And our sin squared theta is equal to 1 minus cos squared theta. Don't forget this, my guy. It's very, very important. Right? So now let's go back to solving those questions now. Right? I'm sure all these tools, if you have forgotten about them, you've revised them, right? So let's get to those questions one by one. So let's see. So if you're given a situation like this, the first thing that you do, you ask yourself, what is the value of tan theta? Tan theta is equal to opposite over adjacent. So we check this value of ours, we can see that it is only a whole number. So you can place over 1. Any number, it is the same as over 1. So it means that this k is our opposite and this one is our adjacent. So we are going to draw our cute triangle like that. I know that it's ugly, but it's cute. So like that. So we can place your 38 there, right? So this will be your 38 degrees. So your k is the opposite, so this is k, and this will be 1. The next step, you can see that you are not having this side. So now we use the theorem of Pythagoras, right? So we know that our r squared is equal to our x squared plus y squared. So r squared becomes 1 squared plus k squared. So r becomes the root of 1 plus k squared. So we can place it there. 1 plus k squared. So the next step is to solve this. So also ask ourselves that if this is 38, this is 90, what will become this? So we subtract that, all those from 180, and we get 52 there. So now let's solve these questions. I hope this 52 is visible. So let me just write it here. So this is representing this angle there. So let's solve this. So this obviously we use reduction angles. So tan of 142. 142 falls in the second quadrant, and in the second quadrant we use 180 minus theta. So this becomes tan 180 minus 38. So this, just because it's in the second quadrant and tan is negative, that becomes negative tan of 38, right? So we check here on 38, what is tan? Opposite over adjacent. So this becomes negative k over 1, just like that. So that's our answer to this one. Number B, it is saying cos negative 38 degrees. So negative 38 falls in the fourth quadrant, right? And cos is positive, irregardless of this negative. So it means that this is the same as cos 38, that is positive. Now we're going to check cos 38 according to this. Cos is adjacent over hypotenuse. So this answer of ours becomes 1 over the root of 1 plus k squared. And we are done with this one. And lastly, they said sine 52. So this is where 52 is, and sine is equal to opposite over hypotenuse. So sine of 52 degrees is the same as 1 over the root of 1 plus k squared. So now you have seen how to solve this. So no matter how the situation is, no matter how you are given, this is the procedure that you do, right? Maybe they will differ here and there, but this is the procedure. So let's go to the second type of question. So let's see this one now. So how do we deal with this one? So you can see that you are given this statement and also this statement. So whenever that you are given that type, it means that we are drawing a Cartesian plane, a cute Cartesian plane, like that, right? And also we have to solve this as if we are trying to solve the equation, but we must remain with the ratio this side. So that will be 7. Sine theta is equals to -4. So our sine of theta becomes -4 over 7, right? So here it is saying sine theta is a negative value, right? So sometimes we find a positive, sometimes a negative, but in this case we found out that sine theta is a negative value like that. So you check your quadrants. Where is your sine negative? So your sine theta is negative in the third quadrant and the fourth quadrant. Done. And then you also check this second restriction. They said cos theta is greater than 0, so it's positive. And also check where cos is positive. So cos is positive in the first and fourth quadrant, right? So both of these statements are satisfied in the fourth quadrant. So it means that that's where our solution is. So that's the first step. You identify where your solution will lie. So our solution will be in the fourth quadrant. So I'm just going to draw a acute triangle again. So that's our theta, right? Now we fill these values. We know that sine is equals to y over r. So this our r becomes 7 and our y becomes -4. So r can never be negative, it will always be positive. So now we don't have the value of x. We can find the value of x. We know that our x squared plus our y squared is equals to r squared. Still using Pythagoras, right? So our x squared becomes 7 squared minus -4 squared. Our x squared becomes 33, so root there, right? So it means that our x is plus or minus root of 33. Now we check which quadrant are we talking about. Is the first is this quadrant, this side, right? So our x is positive there, so we can just remove the negative. So now we'll be left with root of 33 as positive, right? So now let's solve what we're given now. They said we must solve 1 minus 49 cos square theta. So our first step, that's 1 minus 49. And you look here, what is the value of cos? Cos is adjacent over hypotenuse. So this will be root of 33 all over 7, but all these are being squared. Now we can solve. So this will be 1 minus 49 and then 33 over 49. So our answer becomes 1 minus 33, which is minus 32, like that. And you can move to the last one. They said we must solve for cos theta multiplied by tan of theta. So it is actually nice if we start by changing this. So this becomes cos of theta multiplied by, we say tan theta is sin theta over cos of theta. And now this and that can cancel and we're remaining with sine of theta. And the value of sin theta already we are having is -4 over 7. So this is -4 over 7. And we are done with this second type of trig question. No matter how it comes, this is the same way that you solve it, right? So hopefully when we get to the grade 12 part, I'll also show you how to solve the grade 12 one. But still, the same methods. Nothing is different from grade 11 to grade 12. So now, let's move to the third type of trig question. So how do we solve the third type of trig question? This one we use the reduction, we use the identities to solve this, right? And also knowing your angles, where are they positive, where are they negative, right? So let's start with this. So it is saying 2 sine 90 minus. So already we talked about this 90 minus, that this changes to be cos. So this is 2 cos of x. And this one is also saying 90 minus, so it will also change into sine of x, like that, right? If I've copied this correctly, yes, all over. And now let's take a look at this now. What happens with this? So here we're having 2 cos 90 plus x. 90 plus x. So if it is 90 plus x, it means that it is going to change into what? Into negative sign. So this is 2 negative sine x, and 180 plus, this falls in the third quadrant. So this is the third quadrant, and sign is negative there. So that would be negative sine x. Can you see that? So we solve that step by step, no rush. So this becomes 2 cos of x minus sine of x all over. So this is negative 2 sine x plus sine x. So this will be 2 cos x minus sine x all over negative sine of x, like that, right? So now we're having fractions like that. So you can do this. You know that if a plus b is over c, you can partialize as a over c plus b over c. So let's do the same there. So this becomes 2 cos of x over negative sine x minus sine x over negative sine x, like that, right? So the next thing now, it means that this will be 2, and we said cos over sine becomes what? This becomes 1 over tan of x, and negative can cancel now. This will be plus 1. So our final answer now, it is 1 minus 2 over tan of x is our final answer. You just follow through the question, you get to the answer, right? So now let's go to the fourth type of question. So on this fourth type now of trig question, we can see how it is proving the identities. So still we use the identities to prove that, right? So our left hand side, it is cos squared theta plus sine theta multiplied by cos of theta multiplied by tan of theta, right? So it is wise to always change tan of theta first, right? So you can change tan of theta into sine theta over cos of theta. So this end that can cancel out, and we'll be having cos squared theta plus sine squared theta, and cos squared theta plus sine squared theta is equals to 1, which is equals to the right hand side. So now let's move to the general solution. So let's see the fifth type now. So general solution. So what happens with general solution is you try so much hard to change everything into the same ratio. So with this that we are having, we can see that this is having a squared. Let's try to change this into cos, right? So this becomes 3 cos theta plus 3 being equals to 4. Sin squared theta, we said it's equals to 1 minus cos squared theta, right? So this is 1 minus cos squared theta, like that. So this 3 cos theta plus 3 becomes 4 minus 4 cos squared theta. So you can turn everything this side now, right? So when you turn everything this side, so this becomes 4 cos squared theta plus 3 cos theta minus 1 is equals to 0. And we're having 3 terms, the other one with a square. It means that we can factorize. If your factorization game is not good here, you can change this into x and also this into x. I know that you are good with working with x's, right? So you can get this. but anyway, so this will be 4 cos theta. Yes, cos theta and 1 there, and plus minus there, right? So which this will mean that our 4 cos theta is equals to 1, or our cos theta plus 1 is equals to 0. So our cos theta is equals to 1 over 4. Our cos of theta is equals to negative 1. So now we are at the position of finding the general solution now. So what do we do now? Finding the general solution. If you are having a negative value there, please don't put it in the calculator to find the reference angle. Always put a positive number. So reference angle. So this is the same as cos second function of 1 over 4. So mind you, if it was a negative there, you are not supposed to put it. You put it as a positive like that, right? And I'll explain. So what do we get? So second function cos of 1 over 4. I got 75, comma 52, right, as my reference angle. So now with the reference angle, what do you do now? You check here now. Is this positive or negative? According to this, this is positive. So it means that our cos is positive. So you check where cos is positive. So cos is positive in the first and fourth quadrant. So you use the reduction in the first and fourth quadrant to find the solution. So in the first quadrant, this is just theta will be equals to 75,52 plus k times 360, where k is the element of integers, right? So we include this in the general solution, right? So that's the first quadrant solution. So in the fourth quadrant now, it will be theta is equals to, so in the fourth quadrant, we use the reduction formula 360 minus, so 75,52, the reference angle that we got, right? Plus k times 360, where k is the element of that. So what do we get? So we get our theta as 284 plus k times 360, where k is the element of integers. So that's the fourth quadrant solution. And we also take a look at this other solution that you got. It was saying cos of theta is equals to negative 1. So do a second function of this to find the reference angle. So this will be cos of what? Of 1, not of negative 1, but of 1, because I said we don't include the negative 1, right? So our theta, it is saying 0, right? So that will be just theta will be equals to 0 plus k times 360, where k is the element of that. And that's the end of this general solution. Don't worry, I'm also doing general solution on the next question, because we are solving the equation, and I said solving the equation means the general solution. So we are on the last question, right? So as I explained that solving the equation, we first do the general solution, right? So let's deal with this one. So anything that you find to the right of your or that's in the bracket of your ratio, we don't touch it, right? So now it means that we can find the reference angle. And I said on finding the reference angle, don't include the negative. So we can do the second function of sine and put 0.577 as positive, right? So you can do that on your calculator while I'm also doing this. So I found out that my reference angle is 35.24 degrees. That's my reference angle. Now it means that I'm going to check this situation here. It is saying negative. And I'll ask myself, where is sine negative? So that's the third and fourth quadrant. So it means that I'm going to do the general solution of the third and the fourth quadrant using the reduction formulas of the third and fourth, right? So this animal that I didn't use there, it means that my theta plus 20 degrees in the third quadrant, right, equals to 180 plus the theta that I found as my reference angle, 35,24 plus k times 360, which is the what? The period of sine, where k is the element of integers. So now it means that my theta becomes, after solving everything, so it's 180 minus plus that, and then minus 20, which is 195,24 plus k times 360, where k is the element of integers. So this is my solution in the third quadrant, right? And my solution in the fourth quadrant now becomes theta plus 20. So this is third, this is fourth, will be equals to 360 minus 35.24 plus k times 360, where k is the element of integers, right? So after punching, my theta is equals to 304 plus k times 360, where k is the element of integers. So firstly, I've solved this general solution of this. Now what's left is to solve the equation now of this. So on solving the equation, you remember where we were just placing the k as the integers. So what happens is that now, after finding your general solution of that, you check your restriction. So they said my angle must run between 0 and 360 degrees. So I'm going to take this solution in the third quadrant, and I'm going to substitute the integers from -3, -2, -1, 0, 1, 2, 3, right? I'll substitute on the value of k repeatedly. So, right? So any value that I find that it is fitting here, it is my solution, right? So after punching this one of the third, I'm only finding 195.24 as my value of theta, right? So this is the only one that is fitting on this quadrant. If you substitute 2, it will be way over, right? If you substitute 1, it will be way over 360. If you substitute a negative, it will be way past in the negatives, right? So go to the fourth quadrant one. Also, my theta is just 304.76 degrees, right? In the fourth quadrant. So also, if you punch this 304, is this visible? Plus k, if you substitute k as 1, multiplying it by 360, you find out that your value is way past that 360. That's our what? Our restriction there. And also if I substitute by -1 there, -1, also it will be way past in the negatives. So now it means that we have solved the equation like that. So I hope you enjoyed this. So before you leave, don't forget to subscribe. Please subscribe. I'm still here. I'm still going to help you. So next time we meet, I'm going to be talking about the compound angles and how to prove the compound angles. And the other chapter is on how to work with the compound angles. I hope you enjoyed. I really enjoyed myself with my 6 type of trig theory. Thank you.